right, we're going to start our new unit, Unit 8, and this one is so huge in its importance in statistics. We've done a lot of just the computing of getting those probabilities and such, but now we're going into hypothesis testing and talking about what we can infer to the whole population from our numbers. Okay, what do our numbers say about what we're trying to figure out? So, in short, a hypothesis test is going to tell us yes or no as to the plausibility, if what somebody's claim says seems reasonable, or if we have evidence to reject that. Okay? Now, we skipped this little component, but there is this thing called a confidence interval where we can actually estimate a value. So if we wanted to estimate the proportion of Aledo High School students who wear a certain kind of shoe or whatever it is, then we could do that with a confidence interval. But we're going to today start with hypothesis testing. We're going to first learn what this idea of a null hypothesis statement is and what an alternative hypothesis statement is. We'll also learn what this thing called a parameter is, because in past years we've learned that when we did confidence intervals, but we're going to end up learning what this thing called a parameter is. We will not have to check the conditions to make sure the normal model applies. We've kind of talked about that a little bit, but we're just going to kind of go past that and from now on and not get too deep down into all of the checking of the conditions. So let's do it. Let's talk about what this thing called a null hypothesis and an alternative hypothesis are. So the null hypothesis is the claimed value. What is supposed to be happening? It's always setting the parameter equal to what the number that is claimed to be. So for example, the h with a little o, and then you do a colon, and then you are defining this variable, whatever that is. If this is P is the proportion of orange M&Ms out that the M&Ms company makes, or whatever, then that would be equal to 35%. So that kind of brings us to this part we had skipped. That parameter is the variable or the value, the variable that you are inferring about. Okay, it is a value for the entire population. All right, so like I said, down here, if we had defined P as the proportion of orange M&Ms the M&Ms company makes, then that would be claiming that P is 0.35. Then, if we are suspicious that that might not be the case, then you can state how you think that compares to the claim. So we would say that the parameter is less than or greater than or not equal to 0.35. We do not put another value in there. We do not say, oh, I think it's actually 32%. No, you don't claim another number. You just say if you think it's less than, greater than, or not equal to the claimed value in the null hypothesis. All right, so here's just a quick little visual again. The null hypothesis, if it's a proportion problem, we define it and say P equals a number. And if it's a mean problem, we define it with this mu and say mu equals that number. And then HA stands for the alternative, colon, and then we would say either P is one of those things compared to the number, or mu is one of those things. All right, here we go. So this is our first example here. We're going to see that a car dealer advertises that its new subcompact model gets 47 miles per gallon. But you assume that the dealer will not underrate the car, but you are suspicious about the claim. So you're not sure it's getting quite 47 miles to the gallon. So first I want you to write the parameter. What is this problem about? So your first decision is actually, is it about a proportion or is it about a mean? And so when you see percentages, we've seen that in the past. So when you see those percentages, right, then we are going to be talking about a proportion. But whenever you see, another kind of quantity value, then that's going to probably be the problems that are about the means. Okay, so here I think it's going to be about means. So let's define what this problem is about. Mu is the variable we are defining. And that is the average. So you'll always start with the word average or proportion, depending on if you were defining from average or proportion. Average miles per gallons of all these types of new subcompact cars. So the average of all of them, not one, not a sample from that dealership, but all of them. Okay? Now, what would the null hypothesis be? Well, that's the claim. And what is he claiming? That average miles per gallon of all such new subcompact cars is 47 miles per gallon. So here we would write that like this. HO with the colon, and then define the variable. Mu equals 47 miles per gallon. And then we are suspicious about that. We don't think it's necessarily that good. So we think he's getting less than 47 miles per gallon. So that's our alternative, colon, mu is less than 47 miles per gallon. Now, a couple of quick things. Make sure that your parameter is we are always inferring about the cars now or the cars that we're making in the future. It is not about the ones that we got in our sample. So do not say the average miles per gallon of those new subcompact cars, or the ones that were on the lot, or anything in past tense. We don't infer about the past. We infer about the present or the future. And then, of course, you know that null hypothesis is always an equal to. And then this alternative, of course, is based on what we are investigating, what we are suspicious of, which in this case, we thought it was actually less than. Okay, so let's let you try one. Here's our next one. A package delivery service claims that it takes an average of 24 hours to send a package from New York to San Francisco. An independent consumer agency is doing a study to test the truth of this claim, since there have been several complaints about the company not meeting its delivery times. So some people have complained that it's not getting there in 24 hours. So your first question, is this a mean or is this a proportion problem? Well, I see it says the word average in there, and I don't see percentages, so I think it's a mean problem. So I'm going to define what we're making a claim about. Sometimes they say it in the words. Let's see. Package delivery service claims that it takes an average of 24 hours to send a package from New York to San Francisco. So I'm going to say the average hours to send a packages from New York to San Francisco. And I might even say, with this delivery service. Now, I might even want to be that specific because we're not just talking about all delivery services. We're talking about UPS or whatever, FedEx, whichever one it is, okay, with that particular delivery service. Now, the null hypothesis, okay, and the reason we're specific when we state our information is because, do you remember when we would do experimental design? Who can you really generalize these findings to? See, that's what we're doing is we're saying, here is who we're going to be able to generalize to. So keep that in mind as we're going through what our statements are. Okay, so of course the claim HO colon mu equals 24, but I think it's actually, look, how would the complaints be? if it's less than 24 hours, not equal to, or greater than. Well, I think you know that would be, we would be unhappy if it was greater than. Okay, try the next one. The company's manufacturing these ball bearing parts for precision machines, so it has to be just right. The average diameter of a certain type of bearing should be 6 millimeters. Is the average diameter correct? Well, let's see. So mu is going to be that average size in millimeters of all such. And when I use this word such, it's kind of the magic saying, all of these kinds, without me having to be, say, of this particular company. I could say that. Such is also kind of that little magic word that says, the ones that I'm talking about that are like these. All right. The null hypothesis is that mu equals 6 millimeters, but what is our alternative? Do we suspect a smaller or bigger? I don't see anything investigating smaller or bigger. I think we're just seeing if it's different. So if we're just seeing if it's different, then that is our not equal to. Okay? Not equal to. All righty then. How about this one? In 2016, 16.1% of all heart attack patients died from any cause in the first 30 days after being admitted to the hospital. Okay, so wow, 16.1% died within the first 30 days of being admitted to the hospital. So there's been a recent national effort since to improve the quality of heart attack care at the hospitals. Have those efforts improved the heart attack death rate for any cause in those first 30 days of being admitted to the hospital? Okay, remember our first question, mean or proportion? Well, hopefully you see that here, percent. Okay, so I'm thinking proportion. So I'm going to define P, the proportion. Okay, so thinking it's like all heart attack patients who die from any cause in the first 30 days after being admitted to the hospital. Okay, so P is proportion of all such heart attack patients who die from any cause within the first 30 days after being admitted to the hospital. Okay, so sometimes you can find that wording directly in the problem. Null hypothesis would be that claim that it was in 2016. We want to see, is it still that? So we start off HO colon P equals 16.1%, but HA, P is less than 16.1%. Okay, because we want to see if it has improved, and improving would make that death rate go down. All right, let's try this last one here. A team of eye surgeons has developed a new technique for risky eye operations to restore the eyesight of people blinded by this certain disease. So those are the people that this problem's about. It's people who are blinded by a certain disease and then have this type of eye operation. Do they get their eyesight back? Okay. Under the old method, it is known that only 30% of the patients who undergo this type of surgery recover their eyesight. Can we justify the claim that the new method is better than the old one? All right. So what do we think? First, proportion or mean? Well, I see percentage, so I'm thinking it's a proportion problem. So what does P equal? So it's the proportion of the patients who undergo this type of operation who recover their eyesight. Okay. Proportion of people blinded by this particular disease who undergo this new technique. So in your parameter, we also frequently put the treatment. Okay, that's the thing, is that I'm testing out the results of this treatment to see if those are different than what they have been. So that treatment is in your parameter. So the proportion of people blinded by the new disease who undergo this new technique and have their eyesight restored. Is it still 30%, or has it shown a significant increase? Okay, I think that that's all those problems. Hopefully you are getting more comfortable with writing those parameters. Very, very important. Present tense, make sure you state those, the proportion ones especially. Are difficult because you really need to be careful on what's the denominator and what's the numerator. Making sure that you include your treatment in the parameter, okay, so that it is clear who are we generalizing to and what are we inferring. All right. So I hope that helped you, and we will practice some more of those tomorrow.